All right, today we're going to begin work on Module 6, which is on linear inequalities. We're going to start today with Lesson 6.1, which is on writing and graphing inequalities. It's really just the basics to make sure we understand exactly what an inequality is, how to represent them with graphs, and how to interpret a graph given when it deals with an inequality. All right, so first of all, an inequality, very, very similar to the same concept as an equation, except an inequality is going to have instead of having an equal sign between two expressions, is going to have one of our inequality symbols between the expressions. So, if I look at it, the ones I have listed up here, that would be less than, greater than, less than or equal to, greater than or equal to, or not equal to. These are all inequalities. All right, so an inequality is the same concept as an equation in that there's a left and a right side. The difference with an inequality is in an inequality, we're saying they're not equal to each other. The left and right side are not the same. One's bigger than the other, or they don't equal each other at all. Okay. So this greater than symbol, and I just kind of want to run through this just because sometimes we don't uh, determine which one's which. Some people just say, well, these are the greater than or less than symbols, but they don't know there's a difference. So here's our greater than symbol. And basically what we're saying here is when you use this one, it signifies that the first number has to be bigger than the second when you read it left to right. And the key to it is to read it left to right in an equality symbol. Okay, so here's our less than symbol. When we use a less than symbol, we're saying the first number is less than the value of the second number. Greater than or equal to. Okay, now with this little equal to underneath, what we're saying is the first value is greater than the second value, or the first value could be equal to the second value. Okay, so it gives us a little bit more there to work with. Our less than or equal to, again, we're saying the first value is less than the second value, or the two values are equal. And then the not equal to, this just means the left and the right side do not equal the same value. Okay, so the first number is not equal to the second. Okay, first thing we'll do is do some simple translation. So we're asked to write an inequality for the statements. 3 is less than or equal to A. So you just want to write it left to right, just like you read it. So 3 is less than or equal to A. Now, when we write our inequalities, we typically want the variable on the left. All right. And we can switch these two, but the key is if I switch these two, I got to switch the symbol too. So this 3 is less than or equal to A is really the same as A is greater than or equal to 3. Okay. I just switched the two sides like I do with an equation, but because it's an inequality, I got to switch this too. All right. So these two are the same thing. Next one, X is greater than -7. That one's pretty straightforward. And the variables on the left, as you see, and that's where we like it. C, 9 is less than Y. So 9 is less than Y. Okay, again, if I want to write it with the variable on the left, which we typically want to do, I'd write it as Y is greater than 9. That means the same thing. All values of Y are greater than 9. This one says all values of Y are greater than 9, or 9 is less than all values of Y. Same thing. A is greater than or equal to -16, exactly as it looks. A is greater than or equal to -16. I did want to just show you how we can switch the two sides here. You can do that with any inequality. If you switch the sides, you got to switch the symbol. Okay. All right, little application. So for each value of u, determine whether it's a solution to this inequality. U is less than or equal to 12. So what we're looking for here are all values of u that have a value that's less than or equal to 12. So really, here's my u values. All I'm going to do is substitute them in and then ask the question, is 11 less than or equal to 12? Yeah. Is 12 less than or equal to 12? Yes, because it's equal to, right? Is 16 less than or equal to 12? No. Is 8 less than or equal to 12? Yes. Pretty simple stuff here. All right, now we're going to do x is greater than 12, and here's my choices for x. So is 11 greater than 12? No. Is 5 greater than 12? No. 10 greater than 12? No. Is 13 greater than 12? Yes. Okay, so pretty straightforward there with those. Okay. All right, now we're going to write some inequalities for a situation. And what they're doing here is giving you some different terminologies that you have to kind of think through when you write your inequality. do a little reasoning here. So the first one says the temperature inside the lab refrigerator is less than 45 degrees Fahrenheit. Use T to represent the temperature in degrees Fahrenheit of the refrigerator. Okay. So in this case, I want all the temperatures to be less than 45 degrees. So it's going to be T is less than 45 degrees. Every temperature value, okay, that I could put in place of this inequality has to be a number less than 45. Okay. Next one, the distance to the nearest exit door is no more than 200 feet. D is going to be the distance. So no more than 200 feet means that every distance has to be less than, that should be a 200, guys, sorry. Every distance, D, has to be less than or equal to 200 feet. Because no more than means it could be 200 feet, but it's got to be less than that. So it should be here, D is less than or equal to 200, not 20. To get the 10% discount, a shopper must spend at least $200. So you got to see that as the minimum you can spend is 200, but it's got to be 200 or more. So D is the amount we're spending. So D has got to be greater than or equal to 200. Okay. You got to spend at least $200. So that's 200 or more. Laura exercises no less than 50 minutes a day. So she doesn't exercise less than 50 minutes a day. So if she exercised 50 minutes, that'd be false because she never exercises less than 50. Okay. So we want to be greater than 50. T is the amount of time she exercises. That's got to be greater than 50. So this is just some different terminology rather than just giving you flat out greater than, less than, make you think a little bit as to how to write the inequality. Okay. All right. Next concept. Now we're going to write a one-step inequality to represent a scenario. So a one-step means there's addition or subtraction or multiplication involved in it. And again, here we have to kind of really make sure we read carefully as to how we're going to write our inequality. So the first one says 9 subtracted from x is greater than or equal to negative 27. So 9 subtracted from x looks like this. It's x minus 9. Okay, x minus 9 is greater than or equal to negative 27. All right, next one, 4 decreased by a number x is less than 25. Okay, so 4 decreased by a number x. So 4 decreased by a number x looks like that, 4 minus x. And that's going to be less than 25. Okay, C says the sum of 9 and x. Now, when we say the sum of, that means we're adding those two together. So the sum of 9 and x is greater than 16. 9 plus x is greater than 16. D, a number b increased by 3 is greater than or equal to 28. So increased means addition. So b plus 3 greater than or equal to 28. Again, things you've done before. Okay, now looking at graphing here a little bit. Okay, so what's the difference in a graph that involves just a greater than or equal to symbol versus just a greater than symbol, the one below it? So how do we differentiate this? Well, what the equal to does is it fills in the circle on the number that we're using to graph, indicating that that number is one of the answers. So in this case, I want to graph A is greater than or equal to 6. So my graph should be all numbers greater than or equal to 6. So those numbers start at 6 and go to the right. To the right is greater than 6. Okay. Now, I'm putting a closed circle on 6 because of the equal to is saying, well, I can't have 6. 6 is an answer, as well as every number to the right of 6, because those are the ones that are bigger. So there's your closed circle. Look at this one. N is less than 7. Okay, so now I'm saying I want all numbers that are less than 7. Now 7 is not included in that group because 7 isn't less than 7. So we're going to put an open circle on 7 saying, well, we're going to go right up to 7, but not included. So all numbers less than 7 are numbers to the left of 7. Okay, this next one, y is greater than negative 1. So greater than, again, is an open circle. So we're going to put an open circle on negative 1, and numbers greater than negative 1 are ones to the right. And then the last one here, x is less than or equal to negative 6. Okay, so less than or equal to means closed circle, and then numbers less than negative 6 are the ones to the left. Right? As you go to the left, you get smaller on the number line. As you go to the right, you get bigger. So numbers less than negative 6 are to the left. Okay. So open circle, closed circle. Here's another look at it, just a different way. Now they're giving us a graph and saying you write the inequality. So what's going on here? Well, I got a closed circle on -1. That means it's an equal to symbol, and they're shading everything to the right, so that's bigger. So they're telling us to use x for a variable. So this would be x is greater than or equal to -1. All numbers bigger than -1, including -1. X is greater than or equal to -1. Our next one, open circle, means we're not including 5, but everything close to it. So this one's going to be x is less than 5. All these shaded numbers are numbers that are less than 5. This one's going to be x is greater than 5. Again, no equals to symbols on these because they're open circles. And then down here, less than -2, and we're including -2, should look like this. X is less than or equal to -2. All right. So that's pretty straightforward there. So that's all the concepts we're going to work on tonight. Your homework follows this on Alex, very close to the same questions. Take your time, get 100%. If you don't get something, go back and redo it. You know you have that ability. All right. Make sure we're getting the homework done. Stay caught up, and I'll talk to you later.